Good afternoon. My name is Dan Funk. I work in the Office of Nuclear Energy. I'm in the Office of Advanced Innovation in Nuclear Energy, NE-51, for which Tom Miller is the director. And we both work for Shane Johnson, who's the Deputy Assistant Secretary for NE5. And I'm here to talk to you today about the NEAMS program, a brief programmatic overview. We have some technical content in the slides. But my job is to give you a programmatic overview. But we have folks online and in the room here who can answer technical questions. And certainly, if you get some technical questions afterward and you want to follow up in the days ahead, we'll be able to field those questions, get right back to you with good answers, I hope. So, nuclear energy, advanced modeling, and simulation. It's a program that's been around a while for now, a few years now, and has evolved over time and has increasingly become more connected to and responsive to the needs of industry, specifically the advanced nuclear reactor vendors. The advanced nuclear reactor industry is got an increasing number of participants, outfits that are aggressively developing new concepts. And for these concepts to have a better chance of being commercialized, they need to be accelerated. That development acceleration can be helped in a number of ways, but a specific and important way is with advanced modeling and simulation tools. And our engagement with these with working groups that have been formed for the different technology areas for advanced reactors have come to the conclusion that they would like to use some of our tools. And in this engagement, we've begun the process of providing them. So you can see here in this slide a little graphic that kind of shows this advanced modeling and simulation capability development. The blue box there, that's the heart of the NEAMS program. You can see that we interface with NE's other advanced reactor and fuels R&D programs by providing them tools and helping them integrate those tools into their research. We also have interface with the NRC and are beginning to work with them in certain aspects. But of course, through the GAIN framework, you see there, that green area underneath the blue box, that's the gateway for accelerated innovation in nuclear. And there we work directly with industry, either accelerating advanced reactor concepts or helping to solve high impact problems that are of importance to them. We believe that this process helps enable transformative scientific discovery. We think that we can solve problems that otherwise cannot be solved, and that we can allow industry to implement innovations that improve the economics of their concepts and help assure commercialization of those concepts. And certainly, we want to help speed the development of their work. Not shown on here are the universities. Why is that? Well, it's because the universities are an integral part of it. That blue box there represents the heart of our NEAMS program, and we invest 20% of our R&D budget in the university involvement. And that's primarily where the universities are involved. That's where we're asking for your help. Now, that said, there are also university involvement in other areas. You've got in some of the other R&D areas and in some of the high impact problems and other projects that we're doing, we directly contract with university participants and get their help. Needless to say, the universities are an important part of our portfolio. Here is the cast of the usual suspects in NEAMS. We've got Chris Stanek, the National Technical Director, and then you see underneath there, we've got our Leadership Council, Jason Hales, Steve Hayes, both from INL, Brad Reardon, who's here in the room with me from Oak Ridge, Tanju Sofu from ANL, also in the room, and Elia Mazzari from ANL. These guys are the heart of the NEAMS program, but they lead a team of very talented researchers with whom we're hoping you're willing to work. The NEAMS mission areas are kind of laid out here on this slide. This is just a quick picture to give you an idea of how it fits together. Today we'll be talking primarily about the product lines because that's where we're asking for help. But you can also see where we manage our high impact problems and some of our NE mission support, for instance, treat modeling and simulation. We also show on here the investments that are made in the area that's managed under Brad Reardon. And there you can see that includes the university programs. It's an important part of our program that we like to feature. Okay, so you can see with the product lines, fuels, reactors, and integration. Taking fuels first, this graphic shows our multi-scale approach to fuel modeling, fuel performance modeling, and to model fuel performance. It's really about mastering the impact of microstructural changes on the physics and the attributes of the fuel and the cladding, and being able to represent that in models and implement it into Bison. And you can see how this fits together from the slide. I won't go into the details here, but if you have detailed questions, we will address them. But in the reactor product line, our focus is primarily right now on SAM, the System Analysis Module, and SHARP. SHARP is the tool suite that deals with pin-to-pin neutronics, thermal hydraulics, CFD, computational structural mechanics, those modules, the capabilities to integrate these modules for multi-physics simulations. It primarily makes use of leadership class computing platforms, but this is where we are asking your help. We want to move this forward into development of reduced order models and methods that can make these tools even more useful to industry where they might not have access to leadership class computing capabilities nor have the time to run those complex simulations. Beneath that, you see the graphic here showing how Proteus, NEC 5000, and Diablo work together and what goes into them. You'll notice here that under Proteus we include MC²3 for the development of cross sections. That's a very important aspect in Proteus that is one of the focus areas for our, you'll see later in our scope where we're asking for help. Then there's the integration product line. The integration product line, as you saw from an earlier slide, is a lot more than just the workbench, but the workbench is the heart and soul of our focus right now, and it's where we are asking for your help in our scope this year. We did ask last year, we did receive some really good proposals, and we were able to fund one of them. We're hoping to continue that, maybe even fund more this next year if we can. Where we got the idea from the workbench was in dealing with the Advanced Reactor Technology Program. NEAMS existed at that time to provide capabilities to our advanced R&D programs, and ART was one of those. And in engaging them and finding out what they really needed was they had some legacy tools they were happy to use in their research, but they wanted to be able to make them work together more easily and more effectively. And that gave birth to this idea of the workbench, where you got workflow management that makes it easier and more effective to get the different physics represented and the simulations accomplished in a comprehensive fashion. Also, you can see how the physics line up here and where there are tools lined up underneath. And so we quickly learned that what we had here was a way for tools of increasing fidelity of physics to be lined up underneath each physics area, and it makes it possible for a research effort to using maybe lower order tools, maybe faster tools that may want to explore a higher fidelity solution in a particular area, to quickly ratchet down and implement those higher fidelity tools. I want to point out the color code here combination. That the production tools are, of course, light gray. NEAMS did play a role in some of those tools in the early years, but the active NEAMS tools are shown in red. And the Castle tools, that's the modeling and simulation hub that we fund, is shown in this other darker gray color. And you can see where even some of those are shared between NEAMS and Castle. But it gives you a quick reference for where the tools are coming from and how they're being implemented. And this is where you'll see later in the scope we're asking for help. So the NEAMS-NE-1 scope. We have two scopes, NEAMS-1 and NEAMS-2. NEAMS-1 is split up into 6 subscopes, as you can see here. Atomistic and mesoscale modeling and simulation of nuclear fuels, microscale fuel performance modeling, core neutronics, thermal hydraulics, integration and demonstration, two-phase flow for LWRs, and that's centered on the use of relapse 7, development of relapse 7 for future use. And then NEAMS-2 is the separate effects of radiation testing for validation of models in Marmot. Okay, so NEAMS 1.1 and 1.2 again are the fuels-related, fuels product line. The atomistic and mesoscale modeling is focused on improving Marmot's predictive capabilities. So looking for either new mechanistic models to be developed in Marmot, or improving and extending the models that are there and their validation basis. And of course, atomistic simulations to enable or inform the development of these mechanistic models in Marmot are also encouraged. NEAMS 1.2, macro scale fuel performance. This focuses on Bison and on coupling Bison and Marmot. Those are the areas where we're looking for help. You can see from this slide what those areas are. Includes more robust and efficient numerical algorithms, extending Bison to other fuel forms that are not supported or under supported. For example, metallic fuels and stainless steel claddings for fast reactors. We're looking also to improve the validation basis for Bison, particularly for 3D problems. I have a slide that I can show you if the question comes up as to an example of that might give you an idea. So feel free to ask about that. In the reactor product line area, we have 2 subscopes, core neutronics and thermal hydraulics. In the core neutronics, here, as I mentioned earlier, the focus is in getting help from you all in MC²3 modeling capabilities. We're looking for proposals that would help improve the solution accuracy, computational performance and efficiency, and the V&V of MC²3. That, as we list here, that can include introducing Monte Carlo approaches, coherent coupling with Proteus, efficient parallelization and numerical algorithms, and advanced uncertainty evaluation techniques. In the thermohydraulics area, we're really looking for help in developing reduced order modeling approaches using NEC 5000 to be implemented into SAM, the systems analysis module. And there's some things here that are listed here that might involve, but this is, so if you have some questions, we'll be glad to answer those. But this is an important and specific area we hope that you all can offer some help in. Okay, for the integration product line, NEAMS 1.5, integration and demonstration, that focuses on the workbench. We're looking for proposals, as we did last year, to integrate high fidelity as well as conventional tools into the workbench. Ways to better automate the analysis workflows used in design studies. Ways to provide a more convenient access to uncertainty quantification, and then things that proposals that might help develop and demonstrate templates of complex system models and provide automated meshing and demonstrate the use of the workbench for practical studies. And I think here we also are looking for proposals that demonstrate the value of the high fidelity NEAMS tools as applied to collaborative benchmarks validation in industrial systems. And we invite your questions on this as to what the priorities, how to discern what the priorities in this area might be. But I think this is in a nutshell. We really want the value of the high fidelity NEAMS tools to be demonstrated. That's really what we're asking you to help us do. NEAMS 1.6, this is the area that we're adding in because we're taking under our wing and starting in fiscal year 2018, Relapse 7. And the aspect of Relapse 7 where we're looking for some help is in the advanced two-phase flow simulation. And so we're looking for proposals to develop a native three-dimensional subchannel capability in Relapse 7 based upon the 7 equation two-phase flow model. And these capabilities, we want to stress, must be tightly coupled to the Bison Nuclear Fuels Performance Code and account for continuous heat flux across the fluid structure interface and the effect of fuel pin cladding displacement on the subchannel geometry over the life of the fuel. Specific experiments are also sought to validate Relapse 7's 7 equation flow model, specifically regarding its advanced features that distinguish it from the traditional two-phase models. And in that sense, the validation data must account for the 7 equation model assumption that there are distinct phasic pressures for steam and water, and also account for validation of pressure relaxation coefficients of the 7 equation model, and include measurement of the distinct phasic pressures and their rate of relaxation toward a common pressure under transient flow conditions. It's a little prescriptive, but it's because we're expecting to take a small step forward in this first approach. Okay, NEAMS-2, separate effects irradiation testing. Here again, this is focused on marmot. We're looking for innovative separate effects irradiation tests of nuclear fuels and other materials that would provide data important to informing and validating mechanistic microstructure-based models of fuel behavior under development using marmot. Fuel systems of interest for which separate effects experiments are desired include the LWR fuel system, both the historic UO2 fuel and zirconium-based cladding, as well as emerging accident-tolerant fuel concepts, and the SFR fuel system, uranium, zirconium, and uranium, plutonium, zirconium metallic fuel, and steel-based cladding. I'm sure you may have some questions on this too. We'll field those, and if we can't answer them today, we'll get back to you with more detailed information. Just want to quickly go through this to make sure we've covered everything. Again, as we've stated frequently, and I'll state it again, collaboration with members of the NEAMS development team residing at DOE labs, as well as end users in industry or regulatory authorities, is strongly encouraged. We believe this helps you define your value to the program more clearly, and makes the proposal more robust and more easily reviewable. So I think that's to your advantage. Running simulations or conducting experiments at DOE labs or nuclear science user facilities in support of the NEAMS toolkit are encouraged, although computation and experimentation at university labs is equally acceptable. We've in the past have seen some folks try to shotgun across these 5 subscopes, or a couple of them. It really is to your advantage to focus on one of them and hit that one hard and get our attention. And we look forward to seeing your proposals, and we look forward to ultimately working with those who get selected. So I know I went through it quickly, but I thought I would give more time to questions and discussion.
So Dan, we'll start by answering all the NEAMS questions, and then we'll go through the other data needs presentations.
Okay.
And then we'll circle back in case there are more questions about NEAMS.
Excellent.
NEAMS topics. So, and as a side note, the NEAMS 2 scope is a NSUF supported scope, meaning that when you do propose in that area, it's with the intention of actually requesting NSUF access for those irradiations. So first question, Dan.
Yes.
For NEAMS 1.2, to enhance 3D multiphysics BISON validation, the multiphysics is in terms of different physics coupling or just BISON plus Marmot?
Let me make sure I understand the question. All right, so they're looking at the sub-bullet, improve the validation basis of BISON, or are they looking? I'm not sure what
we can look for clarification on that one. The next question is, can you elaborate on your example of the need to enhance 3D simulation capabilities and validation of the same using BISON?
Well, I do have an example. We've been engaged with Halden for to conduct a missing pellet surface experiment, and missing pellet surface is a known problem. It's a problem that is important has been important to NEAMS, and is certainly important to Castle and to industry. It's a problem that is three-dimensional, and therefore you need to validate BISON using three-dimensional data, which we didn't have. And this is an experiment that's designed to get three-dimensional data that is useful to validating BISON, and because BISON is in this case would be used in 3D mode to simulate the pellet clad interaction that results from the missing pellet surface defects. So the example, the experiment is one that as it's ongoing, we'll be extracting data. We actually use BISON to help design the experiment. BISON will be used to help analyze the results, but the results themselves will then be used to help validate BISON because of the particular advantage of having the 3D data, which, as I mentioned before, doesn't exist. So I'm not sure if I'm answering the question. But this is just one example. This is kind of a big experiment that would be expensive, but I'm sure we're hoping anyway. I'm not going to say I'm sure, but we're hopeful that there can be some smaller scope efforts that would try to take on three-dimensional problems for which three-dimensional validation is needed. I don't know if that helps.
Are foreign nationals precluded from working on certain codes?
No. There certainly could be. There's certain. I'm not going to answer for all the labs and all the codes, but it's possible that there could be some restrictions for codes used in combination, and but that can be addressed. That can be addressed on a case-by-case basis. But a priori, blanket prohibition, no, there's not.
Does NEAMS support the collaboration between U.S. universities and industry partners that are outside of the United States?
Well, I think the relevance might be less there, only from the standpoint of the need to meet the urgency of meeting our domestic customers' needs. The advanced reactor development firms come to mind, but I would be hesitant to say that we would consider something of less value because it involved international partnerships. Those could actually, if I could foresee where they might actually give us a great advantage by bringing in data, expertise, capabilities that would enhance a project that would work for us even better. So You know, it's a long answer of saying probably would be okay.
Is reduced order modeling only of interest in the thermal hydraulic work scope? It seems that reduced order modeling would be useful elsewhere.
Well, I think implicitly in the fuels product line, Bison is designed to run as a reduced order model, a reduced order tool, based on being informed by higher fidelity mechanistic models in Marmot. So implicitly, we recognize that, and across the board with NEAMS, if there are ways of getting faster running, more compact tools into the hands of users, we would welcome your ideas there. But specifically for this scope, for this call, the reduced order model approach help is for that one subscope.
Now I just got a message from Steve Hayes that he's available to answer questions as well, so I'm going to unmute.
Well, I'd like Steve to weigh in on this if he's willing.
Let me find him, and we will get. Steve, are you there?
Yes, I'm here. I've been muted. I don't know what you want me to help answer. I could address many of the questions that have come up. Certainly, as you mentioned, the reduced order modeling, much of the materials models in Bison, as Dan said, are most certainly reduced order models from something much more mechanistic and sophisticated, oftentimes developed using Marmot or other lower length scale tools, which then require a reduced order model in order to upscale them to Bison. So the answer to that question is, although it may not explicitly be said in the calls for 1.1 or 1.2, that's certainly the spirit of what we're looking for.
Thank you, Steve. That's thank you very much.
The question on foreign national access, some of the codes, particularly in the fuel modeling area, tend to be export controlled. It doesn't mean a foreign national can't have access to them per se, but a security plan and approval of it would be required to be developed. So you can't assume up front that a foreign national will absolutely get access, but it is possible.
Yes, I thank you for that clarification, Steve. What I didn't want to have people go away with thinking that there was an absolute prohibition, but it is an area that has to be looked at on a case-by-case basis depending on the codes and the lab.
The present NEAMS call appears to emphasize ferritic and martinistic steels and metallic fuels more than previous calls. It appears to lay less emphasis on UO2 and zircaloys than previous calls. Does this change signal a long-term shift in the focus of NEAMS?
I think I'd like to let Steve answer that, but let me just say that we've always felt like we were on a trajectory in NEAMS to expand Bison and to cover other fuel forms, and so we don't think of this as a change. We think of it as a continuation of a process that we've been following. It's just that you're seeing that you're seeing the emphasis move to those other forms as we're ready to move ahead. I don't know, Steve, please.
Yeah, I'd agree with you. It's a natural evolution. The UO2 LWR system was attacked first for a lot of reasons, one of which was just to demonstrate the validity of the multi-physics, multi-scale modeling approach. I think we've done that. We're not finished with the LWR fuel system, but it's quite mature. And now we're ready to bring on some other lines of attack, and metallic fuels are certainly a need in the advanced reactor community. And so that's I think you're gonna be seeing that in the next few years for sure.
Would there be an interest in using flow-induced vibration data of a full-scale reactor for use in benchmarking, computational fluid dynamics, and computational structural mechanics codes?
Yeah, we have to be careful about how large our scope was. We felt we had to narrow it down to stay within the realistic boundaries of our projected investment. And so in this case, for this scope, we weren't looking for that. But Tanju Sofu is here, who can, please, would you speak to that more clearly than?
Yeah, these kind of capabilities were pursued under high impact project with NuScale, but it is not within the defined scope. So if there's a proposal submitted along those lines, I am afraid that probably will not be ranked relevant. So I would discourage pursuing development of proposals along those lines.
Right. It's not that those aren't some good areas for investigation, but we have to choose carefully, and unfortunately, we would prefer to be able to open up the door more widely, but it's not to be in this case.
For NEAMS 1.4, are there specific examples on the working fluid or applications where there is a need in modeling the mixing and thermal stratification in large volumes?
I think Tanju should answer that.
Yeah, the specific target application would be a liquid metal cooled fast reactor, either sodium or lead cooled concepts, pool type concepts with large plenum. In system analysis tools, these volumes are usually modeled as perfect mixed volumes, and it is prone to errors. In CFD approaches, too time consuming. It could take several weeks to months to simulate the stratification phenomena in large volume like that. So the thrust of that call is to develop reduced order models that could be implemented in system analysis tools like SEM, and doing that, the development of reduced order model using our CFD tools like NEC 5000. That is the intent of that scope.
Is there interest through NEAMS 1.3 in the development of rapid methods to augment the toolkit's computation of reactivity coefficients in fast and thermal spectrum and advanced reactors?
I believe so, but I'm not sure I have all the specifics on this. So Tanju, would you also chime in?
Sure. MC2 3 is the cross-section generation tool as part of the Proteus code system. It has both thermal and fast spectrum cross-section generation capability. In recent year, we've added transport solver capabilities into MC2 3 to address heterogeneities, and the intent is to improve the computational performance of that solver by parallelization and other enhancements, so that the computation time and computational requirements are significantly reduced to make them more practical.
Thank you, Tanju.
Does NEAMS 1.1 support the work using a combination of the DFT and Marmot codes?
I'm not sure why it wouldn't, based on the scope. But Steve, would you?
Yeah. So in 1.1, the focus is on developing new mechanistic models using microstructural level physics. That includes Marmot as a microstructure evolution tool and enhancements to it. But Marmot only works with a lot of input from atomistic and lower length scale packages that those types of folks use. NEAMS itself doesn't develop any of those lower length scale or atomistic tools. Pretty much all the ones that are needed are publicly available, open source. So researchers use those to generate the inputs they need to marmot, to investigate microstructural behavior, from which they're going to develop a reduced order model that can go into bison. Does that answer the question?
Oh, Steve, we'll see if there's a follow-up. Oh, hang on a second. Looks like we lost our audio connection. Steve, are you still there? Okay, it looks like we lost our audio connection. We are just connecting back up. Okay, Steve, can you hear us again?
Yes. Can you hear me?
Yeah.
How much of my answer did you hear?
We heard the whole thing.
Oh, okay.
So,
Begin after.
Okay, it looks like we're back up. There was a small technical difficulty. It looks like our internet connection decided to drop off for a few minutes. So we'll pick back up with the rest of the NEAMS question. Dan, will these codes be qualified for NRC acceptance?
Will these codes be? That's a question that remains to be answered. Certainly, we're hopeful that our tools will be useful in regulatory space. We are engaging with the research side of NRC to see where they might have an interest in our capabilities and to exchange information. We're also trying to build a good, solid working relationship with them so that their understanding of what we're doing might help provide them with some useful insights, and that they might be able to give us some useful feedback. So the answer remains to be seen. Certainly, NRC has expressed some interest in seeing how our tools might be helpful in evaluating advanced reactor concepts in the future, near future, hopefully. It also depends on how industry uses them. Clearly, some of our tools are already being used to optimize designs, as with NuScale and in the high impact problem that Tanju referred to, but also in other ways to provide reference information to improve their analytics and to enhance their use of their other legacy tools. So there's any number of ways they can be used, and to the extent that they need to be used in conjunction with, for instance, a license application, certainly we would through the GAIN framework try to provide as much help as we could in helping in that regard. They would a lot of it requires the involvement of particular industry. So the answer to the question is it's depending on a number of things, how well we proceed with developing and validating these tools, how they're used by industry and how much industry is prepared to include them and take them forward to the NRC. Is that responsive? I'm trying to be here.
We will check and see if there are any follow-up questions. We are going to move on to the other two presentations, and we will, like I said, circle back and answer the rest of the NEAMS questions if we do have time after the data needs mission supporting work scopes.
Are we doing the benchmark one first or the data needs? Okay. So what I'd like to do is just introduce Brad Reardon, who's going to talk to give the overview of the nuclear data needs. I just wanted to say that in recent months, we have seen an increasing amount of inquiry into nuclear data needs by the advanced reactor industry. It was an area about which we weren't sure what their needs were. It was an area that NE in recent years has not been actively involved in, but now that we've seen this interest in the advanced reactor industry and some of the needs and some of the implications of not having nuclear data, we decided to move into that area, and this is an embryonic step by introducing a modest scope into the NEAP CINR. So Brad Reardon is for those who may have just joined, he's the integration product line lead, a member of the leadership council for NEAMS, and but he is also wears other hats, and in his in those capacities and in the capacity and based on his expertise, we've drawn him in to help guide our foray into this area. So Brad, would you, is that okay? All right.
Yeah. Okay. Excellent. Okay, thank you, Dan, and thank you for the opportunity to present this work scope today. Let's see. So we're going to talk about some of the nuclear data needs that have been identified as a mission supporting area for the Office of Nuclear Energy. Many of the nuclear data evaluations in the NDEF files maintained by Brookhaven National Laboratory at the National Nuclear Data Center are actually quite old. They've been there for quite a long time. Many of them can be decades old. Several programs are continuously supporting and upgrading the nuclear data evaluations. It's a domestic and an international effort. But many of the needs specific to the Office of Nuclear Energy are not being addressed rapidly enough to address the emerging needs within the office. And so that's why we've added this scope into the mission supporting area under the NEUP call this year. Of course, many of you who participate in nuclear data measurements and evaluations understand the complexity of working with nuclear data, of making measurements in the scarce number of neutron scattering facilities that are available, and then the complexities of analyzing that data and formatting them into evaluated nuclear data files for dissemination out into the community. Just a small sampling of some of the issues that have been raised by industry, regulatory bodies, and research institutions are listed here. Changes in NDEF 7.1 in nuclear data uncertainties have an impact on used fuel validation issues, especially for the uranium-235 and plutonium-239 NUBAR uncertainties that have changed substantially. There was recently some issues raised from a commercial advanced reactor company about the chlorine-35 NP reaction and how that makes a very large difference in the reactivity of their system. There's older nuclear data evaluations or missing nuclear data evaluations that are of a broad interest to a number of different types of especially advanced reactor vendors. We've mentioned in the past things like uranium-238 inelastic scattering, which has a very large uncertainty and can be a limiting factor in designing sodium fast reactor systems. There's missing nuclear data for molten salt reactor systems, such as the thermal scattering for the thermal molten salts, and many others that are out there. We've seen some recent preliminary data introduced for graphite scattering, which makes a very large impact on the treat reactor. And so we've seen studies showing about a 900 ppm impact on the reactivity of treat just due to changing the thermal scattering kernel. So these are areas that we need to continue to investigate. And there's many, many other needs that could be identified, and the scope is quite broad because it is a mission supporting scope. And so we're looking for a high impact problem that can be addressed and can deploy nuclear data for use in resolving a particular problem. So this last bullet just says that, if you can demonstrate the applicability through perhaps sensitivity and uncertainty analysis, which has been used in many of these other studies for demonstrating this particular need, then we're open to a broad range of scopes across the entire NE enterprise. So looking in particular at what's listed in the scope for this particular area, we're looking for needs, we're looking for improvements in nuclear data that address these clearly identified needs for, again, the broad range of the enterprise across the Office of Nuclear Energy. So one thing that we really want to emphasize is that these are needed for production work. This is where you have somebody wanting to operate a facility or wanting to design a new reactor or wanting to move spent fuel. And so fundamental R&D is encouraged, but we need to be sure that an end product is achieved and that we have a final nuclear data evaluation prepared for introduction into NDEF as an outcome of this project. I know there are many teams that have some preliminary data in many of these areas, and so we would accept proposals where you can leverage an existing, some existing work that's already been conducted, but use this scope to finalize that data, to demonstrate it for impactful applications, and to be sure that it's deployed into the National Nuclear Data Center for inclusion in the next NDEF release, so that it can actually have impact on our codes and on our analysis results. And again, demonstrating these needs through sensitivity and uncertainty analysis is highly encouraged. Some examples of areas, apart from the ones that I've mentioned specifically in the previous slide, if you go to this link, which is also embedded in the call itself, it's a link to the Nuclear Energy Agency high priority nuclear data needs list, and this is a list maintained internationally that demonstrates a number of the needs that have been identified previously. There are other needs out there. This list is not comprehensive, but it is a good start. And so, again, other needs that we've mentioned previously are things like thermal scattering kernels that need to be extended for a number of different systems, the chlorine reaction for fast spectrum molten salt reactors, and then any other needs that could be cross-cutting needs across all of the different programs, especially as they're integrated by the GAIN initiative that Dan mentioned earlier in this webinar. We want to ensure partnerships with national laboratories and or industry partners to ensure the relevancy of the work, to have a demonstrated need for a demonstrated DOE mission or industrial application system. So that would really bolster the proposal to have an identified need that could be resolved with a new NDEF evaluation, carrying this forward to advance the state of the art for the community. And so with that, that's the scope for this area.
Dan, let's present MS-NE-1 and then answer questions at the end until we run out of time. So we'll have the NEAMS discussion and the MS-NE-1, the benchmark evaluations discussion, until 3:15 p.m. Eastern time. So let's proceed with that, and then we'll get back to involving Brad and the MS-NE-2 questions.
Okay, is this up on the screen? Okay, good. If anyone new has joined in, I'm Dan Funk. I work in the Office of Nuclear Energy, NE-51. I'm the program manager for NEAMS, but this is an area outside of NEAMS, but it's an area that one of my interest areas, one of my assignments, collateral duties as assigned. And I want to give you an overview of, we have in the scope, this is not the first year it's been in here. It's, I guess this is what, the third or fourth year with this scope of for asking for integral benchmark evaluations. And they're focused on two two projects, the ICS-BEP, which is the International Criticality Safety Benchmark Evaluation, and the IRPHEP, which is the International Reactor Physics Evaluation Project. These are OECD, NEA international activities that involve expert groups that are focused on updating and publishing two very important handbooks that support a number of areas, including characterization of reactor cores and methods, neutronics components of multiphysics measurements, validation of nuclear data, including cross sections, and reactor and criticality safety, including modeling, simulation, and training. These benchmark development efforts do a number of things. They compile benchmark experiment data into a standardized format. The advantage there is that they can be readily used to validate computational techniques and cross-section data. These efforts also evaluate the data and help quantify overall uncertainties through various types of sensitivity analyses, and that's potentially very useful to end users. They eliminate a large part of the tedious and redundant research and processing of experimental data that other researchers and analysts and designers would have to perform otherwise. They streamline the necessary step of validating computer codes and nuclear data with experimental data, and they preserve, this is important function, they preserve valuable experimental data so that experiments can be leveraged again and again without having to repeat measurements in a new experiment. This is just a pictorial showing the process. I'm not going to go through this, but you can refer to it and see how that's kind of their workflow for these expert groups. Now, going to the scope here. Let me just do something. MS-NE-1 addresses integral benchmark evaluations, as we said, for inclusion in the handbooks for the International Reactor Physics Experiment Project and the Criticality Safety Benchmark Evaluation Project. We would like proposals that would use existing experimental data and would also support any programs. It's conceivable it could support TREAT or LWRS or fuel cycle technologies or advanced reactor technologies or NEAMS or the hub, CASTLE. Measurements of interest include critical, subcritical, buckling measurements and buckling and spectral characteristics, reactivity effects, reactivity coefficients, kinetics, reaction rate, and power distributions, and other miscellaneous types of neutron and gamma transport measurements. Now, we're not talking here, I just want to make a point, we're not talking about obtaining data and analyzing it and processing it for inclusion in NDEF. We're looking at primarily existing data, maybe even NDEF data that then could be applied to these benchmarks. If there's some crossover with the nuclear data scope, we can address that later, but I'm just anticipating there might be that kind of question because of the apparent overlap here in topically. There's a topical overlap because there has to be, but I think we can articulate the distinctions in scope so you can determine which scope you might want to provide, to which you want to provide a proposal. Okay, so a growing area of interest includes evaluation of transient benchmark experiment data for light water reactor systems such as PWRs and BWRs. Then we've given a couple of awards, issued a couple of awards in the past. We want to highlight those here on this slide so that you can avoid duplication. There's nothing wrong with extending previous work, augmenting previous work, filling in gaps in previous work, but we just don't want you to waste your time. And I believe that John Bess, who's the primary point of contact here, could get you more detailed information on these two that are listed. One is an IRP, an integrated research project that was awarded in fiscal year 15 to to prepare one or more treat transient testing benchmarks. And then there were 2 other projects awarded in fiscal year 16 for a molten salt reactor experiment benchmark, and one in 17 for a reactor physics benchmark evaluation for a power burst facility experiments. So John had another commitment. He could not be on the line, so he's not available to answer questions. I'm a headquarters program guy, so there's probably a lot of technical questions I cannot answer, but I can field them and be responsive as best as possible, and we'll get John best to get back to you with information that you might desire. Just one point he wanted to make sure I included and emphasize that all evaluations must be completed according to the requirements of these handbooks, these 2 projects, and that includes peer review. So I think those are the key points. If there's any questions for that or for the nuclear data, Brad is here, I'm here, and we will do our best to answer these.
Okay. We will just move back in the order that questions were asked. So this is going to be a mixed bag of NEAMS questions, data needs questions. I'll try to separate out the benchmark questions from those. So can you elaborate on the needs associated with NEAMS 1.3 advanced uncertainty analysis for MC²3?
Tanju, would you?
I think it's a general invitation for adding uncertainty quantification capabilities into MC²3 to address propagating the uncertainties associated with the cross sections into the calculations with Proteus. So any creative ideas from university teams would be welcome.
It appears this NEUP call is focused on addressing material science aspects of molten salt reactors. This seems to imply that other NEAMS elements are sufficient for MSR simulation. Is this accurate?
I believe the answer is no, but
no. I think the NEAMS does not particularly distinguish individual concepts, reactor concepts, molten salts concepts, sodium fast reactors, lead cooled fast reactors, and gas cooled fast reactors are within the scope of NEAMS. The OENE's ART program has specific calls addressing the individual concepts, but I think they're presented in a different category.
Right, correct.
In NEAMS 1.1, are you interested in UN fuel and ZR-based cladding material modeling, e.g. fission gas interactions and corrosion?
I was hoping that Steve might be able to address that.
I believe, Steve, are you still on the line?
Yep. Can you hear me?
Yes, we can.
So I didn't get the first part of it was uranium nitride fuel. That we're not specifically asking for that in this call. Not that it might not eventually rise to a level of interest, but there's currently not that much there. What was the other part of that question?
The other was zirconium-based cladding material modeling.
Yeah, so that's fair game, especially if it's a zirconium alloy that's in use or potential use in LWR fuels. Absolutely.
Is there scope in NEAMS 1.1 to develop systematic DFT-generated databases of properties for Marmot that tackle questions such as modeling phase stability and interface energies under irradiation?
So maybe I'll keep going here. I don't think we're looking for database generation in a broad sense, if that's the real heart of the question. If it's developing more limited sets of data needed by Marmot to run specific problems like what are listed in the call, then the answer could be yes.
which specific molten salts are you interested in? And specifically, what energy ranges are relevant here for thermal scattering?
Brad, thank you.
So primarily where the molten salts for thermal scattering are the fly-based salts and also potentially Flynac salts, just because there is some interest in that area. Those are the two that have kind of percolated to the top as far as industry interest.
For the fast spectrum, also chloride-based salts, I think, would be of some interest.
They added, okay, chloride based, not for thermal scattering. So, if the proposed research meets two work scopes, for example, NEAMS 1.1 and MS-NE-2, can the pre-application be submitted to the two scopes at the same time? And this is an NEUP procedural question. The answer is no. One application has to be submitted to one work scope area. So there's duplicate applications. They will be dismissed, and we'll ask the individual to choose one work scope. So, and then the other question for
I just wanted to raise a point too, and ask our NEAP folks here for some advice on this. I have in the past seen situations where two different proposals were submitted for two different scopes, but they linked them in that one was needed to do the other. And that I ultimately, we didn't disallow that year, but ultimately that led to those proposals not being able to compete, because it was competing in two areas with some very, very high quality proposals, and unless you could assure both of them were high enough tier, the other one couldn't make it. So that's not a good way to go. And your comments on that?
Yeah, and this is an important distinction across the FOA. An application should stand on its own, and so the ability to complete the project should not be dependent on any other factors in the selection process, meaning other scopes, NSUF access, those type of things. So just be aware that those considerations are actively discussed in the review period. At this point in time for NEAMS, which codes are being modified or thought to be used for molten salt reactor analysis?
That's a good question. Tanju, would you?
I think the spectrum of the RPL codes that involve MC²3, Proteus, and also SEM for system analysis modules, and NEC 5000 for CFD, and for this, to the extent that the simulation would require response of, for example, the reactor vessel, the Diablo, those would be all applicable to molten salt needs.
So additionally, as the plans continue to emerge, that the CASTLE and the NEAMS programs will be combined at some point in the future. We are interested in combining, especially the SHARP-based CFD and SAM codes into the impact core simulator from CASTLE as well. And I think that would be a really nice collaborative effort.
Those are good points. Thank you both. And of course, we mentioned molten salt. I know they're not referring to FHRs, the fluoride high temperature reactor, but there in those cases where there are fuel forms where Bison would be applicable, we would argue that Bison could and should be used. And there may be some other computational capabilities that could be leveraged that aren't mentioned here today. So,
okay, we're going to move on to some MS-NE-2 questions now. For MS-NE-2, for the MS-NE-2 work scope on nuclear data needs for nuclear energy applications, does this applied code system have any preference for any program designated toolkit?
No, I think any applicable toolkit that's useful for the programs that we've mentioned before that are used for DOE sponsor programs or for industrial applications would be suitable for this.
Is experimental data on drying processes of nuclear canisters in the scope for MS-NE-2? Is experimental data of drying processes of nuclear data canisters in the scope for MS-NE-2? I'm assuming for used fuel disposition.
Yeah, I think this is more about fundamental nuclear data. Sorry, passing the microphone around. So this scope is really more about the fundamental nuclear data that's distributed through NDEF. So to the point that there may be some need for nuclear data in NDEF, then yes. But as far as some sort of mechanical performance or something else, then no.
Could I interject something too, because of the nature of the questions and the interest, which I find very promising. I welcome that very much. I just want to caution, though, that we're making a small embryonic step here. There's not a huge scope amount of funding that goes with this, and it's very important. If you look on the slide with the work scope description, basically the six steps of getting this data deployed to the National Nuclear Data Center for being evaluated and then put into hopefully into NDEF. It's important that we get to that sixth step in whatever proposal gets submitted. Now, I know this is kind of a downer point to make, wet blanket aspect. But if there's a proposal that starts off with the step 1 and 2 and then just hands it off and says, well, somebody else can take it the rest of the way, there's a real risk there. We don't have the financial strength to handle that risk. We really want to see if something of narrow enough scope can cover all 6 steps, fine. But if you need to start somewhere, leverage, as Brad said, leveraging previous work and carry it through across the end zone, get it into to the National Nuclear Data Center, then that's a win.
Okay, the final question is one that I'll answer. The question is how many pre and full applications were received in NEAMS-1 last year, and we don't have the numbers on hand, but this is one of the largest work scope areas that NEUP deals with. So there are a lot of really high quality applications, and if those numbers are available for public release, we will put those out on the website. So thank you, Dan. Thank you, Brad. Thank you, Tanju, and Steve on the line. Thank you for all of your help answering questions.